So on number 5, how you're going to go about doing this is we've already got it isolated. So the square root is by itself already. Okay. So there we go. All right, so we've got the square root isolated by itself. So we've got x equals the square root of 7x. So we're going to square both sides to get rid of that square root. And so that's going to give us x squared equals 7x. Now we're trying to solve for x. So we're going to divide both sides by x. These will cancel. And so I'll end up with x equals 7. Okay. One thing to think about is with radicals, you're going to have to check for extraneous solutions. Okay. So that means you're going to take what you get here and then plug it back into the original to check and make sure that it actually works. If it doesn't work, it's not going to be a solution. So this is going to be 7 equals the square root of 7 times 7. Well, when I do 7 times 7, that's going to give me 49. And I'm going to take the square root of that. And so that's going to be 7 equals 7. Okay, so x equals 7 definitely works. Okay. The next one I'm going to do is 17. Okay, so 17, we did this a little bit earlier today if you're in my class, but it's not the worst case scenario to see it again. Okay, so on 17, what you're going to do is you've got the 6th root. We got the 6th root of 128b squared. Okay, so let's look at our variables first. We have 2 b's, and this little thing right here tells us that we want to make a group of 6. Well, can we make a group of 6 with these 2? No. So they're just going to stay underneath the radical. Okay. We're going to take 128 and we're going to take the 6th root of it. Okay. So the first thing that you always want to do is go into Desmos or go into your graphing calculator, and you're going to type out this root. So for instance, we're going to get 128 raised to the 1/6 power. Notice how that's going to give me a decimal. Okay. So since it's going to give me a decimal and not a whole number, I'm not going to just write out a whole number over here. So I'm going to actually have to break that number down. Okay. So I'm going to take 128, and if it's an even number underneath the radical, my rule of thumb is normally just divide by 2 and then see what you get. So I'm going to divide by 2, and I'm going to keep dividing by 2 until I can't divide by 2 anymore. So I'm just going to keep going and keep going and keep going until I run out of numbers, right? Now my goal is to make a group of 6. So I'm going to try to make a group of 6 of 2's. So I've got 1, 2, 3, 4, 5, 6. So how many groups do I have? Well, I have 1 group of 2's, so that's going to go on the outside, with 1 left over. So that's going to go on the inside. So my final answer is going to be written as 2 6th root of 2b squared. Okay. The next one I'm going to do is 34. Okay, so the next one I'm going to do is 34. Okay, so I'm going to scroll down, and I'm going to move pretty quickly through these. So I would probably suggest just kind of taking a picture of them as we're moving along. And then if I need to go back over something, I can at the very end. But there's just a bunch of people, so I'm trying to hit as much as I can. Okay, so we're doing 34. On 34, it says a savings account balance is compounded annually. If the interest rate is 4% per year, the current balance is $1,978. What will the balance be 6 years from now? Okay, so the first thing that I want you to notice is that you're going to do A times 1 plus R raised to the T power. Okay, so that's the first thing that you're going to do. It tells us that you've got 4% per year. Okay, so it's got 4% per year. So you're going to change that 4% to a decimal. So that's going to be 0.04 for that R value. And we got that 1 plus right here. And it even tells us that we've got 6 years. So 6 is going to go in for that T. Okay. Now it says the current balance is $1,978. That's going to be our A because that's our starting amount that we've got. And now what we're going to do is plug this in our calculator. So we either go into Desmos or going into our TI-84. And we're going to type 1,978 times 1 plus 0.04. And we're going to raise that to the 6th power. And that should give us $2,502.80. And notice how I rounded it off to the second decimal place because we're dealing with money. Okay. The next one I'm going to go over is number 42. Oh, yes. Okay. So in behavior. All right. So with in behavior, the first thing that you want to do is you always want to graph the equation. So we're going to take that, we're going to plug it into Desmos. So we got 2x to the 2nd power plus 16 plus 26. So we've got 2x raised to the 2nd power plus 2x plus, I think it's like, plus 16x plus 26. Okay, so this is my graph. Okay, and you always want to kind of put yourself at 0, 0. So you're standing right here in the middle. Okay, and you're looking as x is approaching negative infinity. So as we're moving to the left, what's happening to our y values? Well, it's going up, right? So that's going to be y approaches positive infinity. Okay, looking to the right, as x approaches positive infinity, so as we're moving to the right, what's happening to our y values? Well, they're also going up. Okay, so looking back at our answer choices, kind of scrolling down just a little bit. As x approaches negative infinity, well, it's not A. And as x approaches positive infinity, as y approaches positive infinity, x approaches negative infinity. Nope. Well, yes. Okay. Sorry, I'm reading these backwards. Remember, f of x is y. It's the same thing as y. So as x is going to the left, that's what it's saying right here, your y's are approaching positive infinity. Yes, that's true. So let's check the other side. As x is approaching positive infinity, so as we're going to the right, what's happening to your y values? They're going to positive infinity. So it is B. Okay. And you do need to make sure that you pay attention to whether it's x or it's talking about y, because they'll try to do this kind of thing where they switch them. But normally your x comes first. That's normally how it's going to be seen. All right, we're doing 47 next. Okay, so 47. Yes. All right. Find the inverse of each function. Okay, so with inverse functions, what you're going to do is you're first going to switch your x and your y. Okay, so we're going to go switch our x and y. And then we're going to try to isolate this y. Okay, so the first thing I'm going to do is I'm going to move 2 to the other side. So I'm going to add 2 to the other side. So this is going to give me x plus 2 equals 1 over y minus 2. Now, y is in the denominator. So we want it in the numerator and we want it by itself. So what we can do is we can multiply both sides by y minus 2. So I'm going to multiply this side by y minus 2 and this side by y minus 2. And that'll give me 1 over here. And this is going to give me y minus 2 times x plus 2. And our goal is to get that y by itself. So we're going to divide by x plus 2. And so this will give me y minus 2 equals 1 over x plus 2. Still want y by itself. So we're going to move that 2 to the other side. So our final answer will be written as the inverse of g of x is equal to 1 over x plus 2 plus 2. Now I know that was a lot of information, so I'm going to give you a second to kind of look that over. So again, the whole point is to switch that x and y and then solve for that y. Next one, I'm going to backtrack just a little bit. I'm going to do 43. Okay, and just like what I said earlier, I'm just kind of going through in the order that I got y'all's requests. Okay. All right. So on this one, we're going to identify the domain and range. Okay. Best way to do this is to plug it into your calculator first. Okay. So we're going to go in here and we're going to type -2/3. And then we're going to take the cubic root of x plus 5. Okay, so there's a couple of different ways you can do this one. So you could do the cubic root by hitting this little keypad down at the bottom and hitting functions. And then going down, it's on here somewhere, the nth root. So then you can type 3 in here, and then it's x plus 2. Okay. Or you can take x plus 2 and then raise it to the 1/3 power. Now, if you're using a TI-83 tomorrow, or whenever you're taking this exam, you're going to hit math 4 for the cubic root, 5 for any other root. Okay. We can't tell you this information. We can't tell you this. You have to have this memorized. Okay. So just keep that in mind as you're doing this. All right, so going back to this, it's x plus 5. My bad. X plus 5 minus 2. Okay, now we're stating the domain and the range. Okay, like I told my class earlier today, domain is your farthest left x value to your farthest right x value, and then range is your lowest y value to your highest y value. Okay. So what you're going to do is I would zoom out just a little bit. Zoom out. Okay. So what's my farthest left x value? Well, it keeps going off the page, right? So that's going to be interpreted as -infinity. Well, what's my farthest right x value? Well, it goes off the page. So +infinity. Okay. For my range, it keeps going up and it keeps going down. So we're going to interpret that as -infinity to +infinity. Okay. And that was on number 43. Now, when it says sketch a graph, you're not going to be asked to sketch a graph on the test, but you just want to give kind of like a rough little, okay, nothing crazy. Okay, I've got a request for 27. So going back up to 27. Okay, so you're not going to be asked to write the equation for this. You'll be asked to identify the equation. So just keep that in mind when you're going through this. Okay, so when you write this equation though, this is an exponential. So that's always going to be in the form of y equals a times b raised to the x, where a is your y-intercept and b is your rate. Okay, so in this one, my y-intercept is 3. And then my rate is from one point to the next, what did I multiply by? So what I mean by that is this point right here is 0, 3. And this point right here is 1, 6. So from 3 to 6, what did I multiply by to get there? Well, that's 2. So 2 is going to be my b, and we're going to raise that to the x. Okay. 45. All right, so somebody asked for 45. On this one, we're domain and range again. Okay. So like I said, best way to do this is to graph it. So this is the square root of 9x minus 9. So we're going to come in here. Square root of 9x minus 9 minus 4. Okay. So my domain for this one, what's my farthest left x value? Depending on how this multiple choice question actually goes, it could say a couple of different things, but for right now, we'll just interpret it this way. As long as it's not a word problem, because keep in mind, you might have word problems on your test, we're going to interpret it just looking from the graph. Okay, if it's a word problem, you do need to pay attention to what it's asking you for. You've got to read. If you don't read, you won't get that question right. Okay, so this point right here, 1, negative 4, is my farthest left x value. So 1 is going to be my farthest left. So domain, we've got 1, and we're going to use a bracket for when it's included. And then what's my farthest right x value? Well, it keeps going on. Okay, so that's going to be represented by infinity. My range, remember, is my lowest y value. So what's my lowest y value? Negative 4. Okay, and what's my highest y value? Positive infinity. Okay, and then if I'm sketching this graph, it's just going to look like that little line. Nothing crazy. Okay, the next one I'm going to do is 35. So 35. Sorry for jumping around. That's just how it kind of fell out to be. Find the inverse of each equation. Okay. We're not going to have a whole lot of logs on there. We're just thinking that you might see it a little bit. So again, you're going to switch your x and y. And we want y by itself. Okay, so we're going to multiply by 3 in the top and the bottom, or I'm sorry, on both sides. So it's going to be 3x equals e to the y. Now we want y by itself. Okay, so last week we talked about how we put it from exponential. Let's just do it one. Okay, so we went from exponential to logs. So let's talk about that. So if we took this equation, okay, and we put this in log form, this would be log of base 2 of 1 equals x. So we're going to do that exact same thing with this one. Okay, so we're going to start with e, go to the outside, and then finish at our exponent. Okay, so watch the magic happen. We're going to have log of base e of 3x equals y. Now, some of your teachers have told you this. Log of base e is the same thing as ln. So if you look at your calculator, you're actually going to see ln on the left-hand side, and you'd have to hit second ln in order to get e. Okay, so that's how those two things correlate. Log of base e is the same thing as ln, which is called the natural log. I don't know if a lot of your teachers have gotten that far. You probably won't see this, fingers crossed. But again, that's us guessing because we haven't seen this test, okay? And I'll give you a second to finish writing that down because I know that probably was a little rough. The next couple ones I'm going to go over are 6, 8, 51, 53, 54, 4, 31, and 32. Okay, so those are coming up. Someone also asked me to go over exponent rules. So I'm going to hit that really quick before we kind of continue on. So if you need to take a picture of this, do it now. Okay. So going over exponent rules, I want to pull up the little cheat sheet really quick. So on here, I think we included the exponent rules. Okay. So whenever I'm doing this one, for exponent rules, I always forget these. I don't have these memorized. I always have to go back to plugging in actual numbers because these look confusing to me. I never memorized it in high school. So let's say, for instance, I have 2 to the second power times 2 to the third power. Okay, that's saying I have 2 2s and 3 2s. Well, how many 2s do I have in total? Well, I have 5. So that's going to be 2 to the 5th. Well, how do I take 2 and 3 and get 5? Well, I added them. Okay. You can do the same concept on this next one, the quotient rule. So you could take 2 to the third power, divide it by 2 to the second. Well, that's 3 2s and 2 2s. You're going to cancel any out. Well, how many are you left over with? 2 to the first power, right? Well, how do I take 3 and 2 and get 1? Well, I subtracted them. Okay. The one that I always have, this is the one that I struggle with to remember. I'm not even kidding. Still to this day. If I take 2 to the third and I raise that to the second power, do I add them or do I multiply them? I always forget this one. So I write it out. If I take 2 to the third power, that's 2 times 2 times 2. So that's going to give me 8. And I'm going to take 8 and raise it to the second power. So that's going to give me 64. Okay. Well, does that mean that I'm going to add these? Because if I added them, it would give me 2 to the 5th, and that's not equal to 64. If I multiply them, that'll give me 2 to the 6th, but that will give me 64. So when you have an exponent raised to an exponent, you're going to multiply the exponents. Like I said, I've never had these memorized. Okay, so just kind of plug in and then kind of see which one works. This one though, you do need to have memorized the 0 exponent rule. If you ever forget, just plug a number into your calculator. Anything raised to the 0 power is going to equal 1. Okay. What's the other one? Negative exponents. Okay, so with negative exponents, that's always going to flip your fraction. So for instance, if you had 3 divided by 2 and you're raising that to the negative second power, you're first going to flip this fraction. And then you're going to raise everything to the second power. So that's going to be 2 to the second and 3 to the second. What's 2 to the second? 4. What's 3 to the second? 9. Okay. There's not really a cute little trick for this one. It's just kind of memorization on that one. Okay. For the person who asked me that, let me know if you need me to go over something else or if you had something more specific. Okay. Okay, so next up on our queue, if you will, is 45. I think we already went over. No, we haven't gotten 45. Did we? 45. We already did 45. Okay. 35 we already did. So we're at 6 now. Okay. Going back to 6. All right. So on this one, okay, you're going to isolate your radical and then solve for your x's. Okay, so I'm gonna write this over here. -6 equals -7 plus the square root of -3 minus x. Okay, so I'm gonna add 7 to the other side because I want to get my radical isolated. So that'll give me 1 equals the square root of -3 minus x. Now I've got my radical isolated, but now I want to get rid of it so I can get x by itself. So I'm going to square both sides. 1 squared is 1. If I take the square root of something and I square it, that just cancels that out. So I'll get -3 minus x. I still want x by itself. So I'm going to add 3 to both sides. So that's going to give me 4 equals -x. I'm going to divide both sides by -1. And so x is going to equal -4. Remember, when we have radicals, we have to check for extraneous. Okay? I'll be perfectly honest with you, you're going to have multiple choice questions. So that means if they give you multiple choice answers, just plug them back in here. You don't even have to do all of this craziness. Okay? But if we did plug it back in and we checked and we simplified, this is minus -4. So if we simplified, that would give us -7 plus the square root of +1. Well, the square root of 1 is just 1. So -7 plus 1 is going to give me -6. Is -6 equal to -6? Yes. So our answer is x equals -4. Okay. Somebody also asked for number 8. So we're going to go over that one. So on 8, we've got x equals the square root of 42 minus x. We want x by itself. Well, it's kind of by itself, but there's also this other piece over here. And we've got the radical by itself as well. So in order to get rid of this radical, we're going to square both sides. When we do that, that's going to give us x squared equals 42 minus x. Since there's that x squared, I know that it's a quadratic. So that means I'm going to move everything to one side and then factor. So I'm going to add x to the other side. I'm going to subtract 42, move it to the other side. So this will give me x squared plus x minus 42 equals 0. And now I'm going to do the dreaded factoring. So the big X, you got a times c, which is -42, b, which is 1. What two numbers will make that happen? 7 and -6. So this will be x plus 7 times x minus 6. If I solved, I would get x equals -7 and x equals +6. But remember, we have to check. Okay, so we're going to have to plug it back in to make sure that it works. I'm going to tell you right now, if you plugged in -7 into this equation, that would be -7 equals a positive square root. That guy's not going to work. So that's an extraneous solution. If we plugged in 6 into this equation, it would work. So your final answer would just be x equals 6. You wouldn't even talk about that -7. Okay. The next one I'm going to do is 51, 53, and 54. So that's coming up. Okay. All right, so scrolling down to 51. And like I said, I will be posting this video after I'm finished. And I apologize for moving quickly. I know there's a lot of y'all. Okay, so for 51, and I'm going to clear this in 3, 2, 1. Okay, so for 51, we're going to switch our x and y, and then we're going to solve for our y. So we switch our x and y, and this is going to give us 1 over y minus 1 plus 1. This is kind of similar to the one that we did earlier. So we're going to move that 1 to the other side. And so that's going to give us x minus 1 equals 1 over y minus 1. We want to get y by itself, but it's in the denominator and it's on the other side attached to -1. So we're going to multiply by y minus 1 on both sides. So this will give us y minus 1 times x minus 1. These would cancel. So equals 1. Still want y by itself. So we're going to divide by x minus 1. These would cancel. I have y minus 1 equals 1 over x minus 1. Still want y by itself. So we're going to move that 1 over to the other side. And so my final answer is going to be written as the inverse of f of x equals 1 over x minus 1 plus 1. Okay. I'm going to go over 53. Okay, so on 53, we're going to switch our x and y. So we've got x equals -2y to the third power. We want y by itself. So we're going to first get rid of that -2 by dividing. So that's going to give us x divided by -2 equals y to the third power. We want to get y by itself. Well, the only way to do that is to take the cubic root of both sides. So this is going to give me the cubic root of x divided by -2. And that's going to be equal to the inverse of g of x. Now notice how every single time I do an inverse function, I go from a y to this weird symbol, right? You've got to write it like this. Okay, that's how your answer choices are actually going to be written. Okay. Okay, next up I'm going to do 54. On this one, they tried to switch it up on you with this whole variable change. Don't let that trip you up. It's still the same thing as an x. Just in your final answer, you want to make sure that you include an in. Okay, I'm going to solve this using in though. Okay, so I'm going to clear this in 3, 2, 1. Okay, so on 54, we're going to switch our in and our y. So this is going to be n equals 3 divided by y minus 2. We want that y minus 2 out from the denominator, and we want y by itself. So we're going to multiply by y minus 2 on both sides. And so these would cancel. Okay, so I've got y minus 2 times n equals 3. Now this one's a little different. We're actually going to multiply out this n. So we're going to take n and we're going to multiply it times y, and n and multiply it times that -2. Okay, and this is different from our last problem, because on our last problem we had x minus 1. We had more than one piece to this n. Okay, so we're going to multiply n times y minus 2n equals 3. We want y by itself, so we're going to move that 2n to the other side. So that's going to give me ny equals 2n plus 3. Still want y by itself, so we're going to divide by n on both sides. So that's going to give me the inverse of f of n. equals 2n plus 3 divided by n. I know this one's a little tricky. You could potentially have something like this on your interim. I would think that they would throw this one in for sure. If you're ever unsure whether or not they're inverses of each other though, remember you can graph them and they should be a reflection over that line y equals x. Okay, if it's not a reflection, they're not inverses of each other. And if you're unsure of their reflection, pick a point of the original function. So like, let's say that 1, 2 is on the original, then that means that in the new function, so in this inverse, it should be 2, 1. Okay, so that's another way you can do it. And it should work for at least 3 points. If it doesn't, then again, not inverses of each other. Someone asked, ooh, Anthony, where did you get the y from? Which one, on 54? Where did I get the y? Okay. Well, I switched. Okay, so you see how this has f of n? Well, f of n is the same thing as y. Okay, so when we're doing our inverse functions, we're going to switch our x and our y. In this case, our x is n. Okay. Does that help? Okay, no problem. Okay, I'm going to go back to number 4. Okay. Okay, so on number 4, what you're going to do is it's asking for domain and range again. So I'm going to take this equation, I'm going to go into Desmos, and I'm going to graph it. So square root of x plus 2. So remember, domain is going to be my farthest left x value. So what's my farthest left x value? That's -2 to my farthest right x value, which is going to be positive infinity. Okay. For range, it's going to be my lowest y value, which is going to be 0, to my highest y value, which is going to be positive infinity. And again, you'll just draw this little sketch. It can be rough on your paper. One thing I do want to mention, you're probably going to see domain and range in context. And I think I said this earlier, but just in case, let's say, and I'm going off script. Let's say, for instance, I have the equation 2 to the x, okay? And let's say that I'm talking about a bacteria population. And let's say that I'm doing it over a course of 2 days, okay? And I ask you what the domain and the range are, okay? The domain is going to be from 0 days, right? Because we can't have negative days when we're dealing with the bacteria growth, to 2 days, because it tells me that in my problem, okay? My range is going to be 1 because I have to start with at least 1, or I have to start with whatever my y-intercept is, to my highest y value, or when x is 2, our y value was 4. So my highest y value is going to be 4. Okay, again, this would have to be in context, and they'd have to give you the equation, and they might give you a graph. It's kind of like our tidal wave problem that we had a couple units ago, the last unit. A lot of people struggle with that domain and range on that one. So just a kind of reminder. Someone said 31 and 32. Faith, that's a good question. I'm getting there. 31 and 32 coming down there. Yeah, okay. So on all of these, you're actually going to use the simple interest formula, fun fact. So you're going to use that a times 1 plus r raised to the t. Okay, so for instance, on this first one, This is going to be your initial, so that's going to be your A value. Your R is going to be your percentage, but you're going to change it to a decimal. So the way you do that is you take the decimal point, you move it over 2 spaces and fill in a 0 right there. So that's going to be 0.04. And we're going to raise that to the 9th power. Okay. Now you're going to take this and you're going to plug it into your calculator. And then you would write, make sure that at the very end you write your $sign and whatever it simplifies down to. So just for purposes, 1, 2, 3, parentheses 1 plus 0.04 raised to the 9th power. So that's going to be $1,750.67. And remember, you do need to round to that second place because we're dealing with money. Okay. On this next one, you actually are still going to use A times 1 plus R raised to the T power. And I think somebody asked this later on in the chat box. How do you know the difference between compounded, simple compound interest and then compounded like monthly and that kind of stuff? Normally for this equation, you're going to have some adverbs like monthly, quarterly, it'll say biannually, that kind of thing. Okay, those will be trigger words to get to here. For right now, you're really just going to see this most often. Okay, you'll deal with this kind of stuff in AMDM, or you'll deal with it in like loans and that kind of stuff. Okay, so if I'm plugging in this question right here, that's going to be 736 times 1 plus 0.05, and we're going to raise that to the 7th power. Okay, and then you'll plug that into your calculator and it'll be in minutes. Okay, I think I did that in my other video, but again, just to make sure you're on the right page, 736 plus that raised to the 7th power. So this will be 1035.63 minutes. I am going to share this with the other teachers. Somebody asked, can I post this in the Zoom? I can post the Zoom. I can post in my e-class. I don't know about your teachers. I'll send them a text tonight and just kind of say, hey, hopefully you don't have the test tomorrow. Maybe you do. Okay, I'll send her a text. I got you. Okay, I hit 32. I hit 31. Somebody said 55. I think we haven't gotten to that one yet. There we go. Okay, so let's go over 55. Okay. All right, so on 55, it's saying find the inverse of the function and then graph the function and its inverse. So you have to do both. So first I'm going to switch my x and my y. Remember, my x is going to be this n and my y is going to be that g of n. Okay, so we're going to get, I'm going to put it in terms of n. So I'm going to do n equals 1 over negative y minus 3 minus 2. I'm going to move that 2 to the other side because I want to get y by itself. So this will give me n plus 2 equals 1 over negative y minus 3. I'm going to multiply by y minus 3, negative y minus 3 on both sides, because I want to get that y out of that denominator. So I'm going to be left with negative y minus 3 times n plus 2 equals 1. I want y by itself, so I'm going to divide by n plus 2 on both sides. And so I get, I'm going to write this over here. I get negative y minus 3 equals 1 over n plus 2. I'm going to add that 3 to the other side. And so this is going to give me negative y equals 1 over n plus 2 plus 3. Now I've got this negative right here. So I'm going to divide everything by that negative 1. So that should give me y equals -1 over n plus 2. And that should also make this -3. Let me check and make sure I did that right. Okay, so I'm going to graph both the original equation and then its inverse. I'm going to show you what I mean by it reflecting across that line. So give me 2 seconds. 1 over -1 -3 -2. Okay, so I'm going to graph both of those in Desmos. So I'm going to come in here. Instead of using n, you're going to use x though. Okay, so when you type this in, just be mindful of that. So this is the original function. So this is going to be 1 divided by -x minus 3 minus 2. Okay, and that second one is going to be -1 divided by x plus 2 minus 3. Okay, I'm gonna hit clear and then I'll bring it back in just a second. Okay, so the line y equals x goes like this. Okay, so it should be a reflection over that. Okay. Should be -3. Okay. And so like I said, you should be able to go, okay, if the point 0, -2.33 is on this graph, then I should have -2.333, 0 on this graph. Okay, so here it is again. So this point, which is on the original function, is right here, is the same thing when you flip it to be on the inverse function, which is right here. Okay, that's how you know you did it right. No problem. Okay. 20, somebody said 35, and then somebody else says 28. 35. I think I went over 35. Okay. Let me hit 28 because I think we didn't do that one yet. Like I said on 27, for 28, remember you're going to take your initial amount and you can assume that's like 1/2. That one's a little tricky. None of your teachers are going to be upset about that. Your rate, you're going to take 0 raised to the 1/2. And then you're going to find that next value, which could be 1,1.75. Since these points aren't really exact, again, finding the rate is kind of difficult. So just be mindful of that. This also has shifted to the right one. So this is going to be x minus 1 in that exponent. And then in order to find our rate, we're going to take 1.75 and divide it by 1/2. So I'm going to go into my calculator. And I'm going to do 1.75 divided by 1/2. And that's going to give me 3.5. 3.5 right here. Okay, so that would be my equation. Again, your teacher might say something a little different because these points are a little hard to see. I'm blind, I'm sorry. But if they have something else, just kind of go with what they're saying as well. Like I said, this one's kind of challenging to see. Okay. 35, I'm gonna go back over that one because I know that's a little new. Okay, so 35, you're gonna switch your x and y, and then you're gonna solve for your y. And we just went over how to do exponential to logs and that kind of stuff last week. So that stuff is taken into consideration here. So we're going to switch our x and y. And then we're going to get that 3 off that bottom by multiplying. So we've got 3x equals e to the y. Now from last week, we worked on writing exponential to logs. So we're going to start at our base, which is e. We're going to go to the outside, and then finish at our exponent. So this will be written out as log of base e of 3x equals y. We learned last week that log of base e is the same thing as ln. So my final answer would be written out like this. Okay. Somebody said 33. So 33, you're going to do the exact same way as 31 and 32. So I'm going to do a times 1 plus r raised to the t. So that'll be 74,100 times 1 plus 0.03. And we're going to raise that to the 7th power. And all you're going to do is just plug that into your calculator. So remember, a is going to be your initial or your y value, your like y-intercept. R is going to be your rate or whatever percent they gave you. Just make sure you change it to a decimal. And then the number of years is going to be that t. Okay, so you'll plug all of that into your calculator. Okay, I think I hit everything that y'all posted. And I did that in an hour. So bravo, right? So really quick, just to kind of get a feel, because there were 46 of y'all on here. I am going to take a screenshot of the people who were in here because some of your teachers were asking about that. So I'm going to stop. I'm going to first stop actually recording. So just be aware. Okay, so 37. If I switch this, because I'm finding the inverse function on this one, right? Yep, and the inverse function. Okay, so if I switch my x and y, so I'm going to get x equals 6 to the y divided by 3. Okay, and then I want to get y by itself. So I'm going to put this in log form. So I'm going to start at my base, go to the outside, and then finish at my exponent. So I've got log of base 6 of x equals y divided by 3. I still want y by itself. So I'm going to multiply by 3 on both sides. So multiply by 3 on both sides. So my final answer is going to be 3 log of base 6 of x equals the inverse function of x. You really have to make sure that, okay, so you really have to make sure that you understand the whole exponential to logs for 37 and 38. So on 38, we're doing the exact same thing. We're switching our x and our y. Okay, and then we're going to put this in log form. So this is going to be log of base 3 of x equals y over 3. Still want y by itself. So I'm going to multiply by 3 on both sides. And so that's going to be 3 log of base 3 of x equals the inverse function. Okay. All right, I got a question on 29 and 30. Malcolm, I can post it to like my e-class, but I don't have access to other teachers' e-class. So I'm going to try my best to let them know, hey, just post it. So I'll try, but I just got to make sure that I give it time to process onto YouTube. Okay. 29. Okay, so on 29, you're doing the exact same thing that we did on 27 and 28. This one, a little bit harder to see, but what we're doing is our y-intercept is going to be probably 1/4. Again, that's a guess just based off of what this graph is showing. 1/4 is going to be our initial. This is also moved over some. Okay, so that's going to be over either once or twice. And this is going to be one that you're going to want to play around with. So let me show you what I mean by that. From 0 to 1, 0 1/4 to 1 comma 1/2. What did we multiply by to get from 1/4 to 1/2? Well, if you go into your calculator and you type 1/4 divided by 1/2, that gives you 0.125. Okay, so I'm going to write that out, 0.125. Okay, so now I'm going to take the equation that I just wrote, and I'm actually going to plug it into Desmos and make sure that it plotted correctly. Now, if it didn't plot correctly, we're going to maybe make adjustments to that to make it work. And I'm just doing this off the top of my head. Okay, so we can even see that it's facing the wrong way. Okay, so how do we flip it? Well, what if we throw a negative out front? What does it do? Well, that's not it. Okay, so we want it to be growth, right? Because it should be growing from here to here. Uh-oh, let me plug my thing in. Okay, so we see that it's going to be growth. Okay, so we need to make sure that that rate is greater . Okay, so we need to make sure that that growth is greater than 1. Sorry, my other computer froze. It'll give me 2 seconds to like. Okay. 2 seconds.